Okay, so today I'll present you uh, a paper entitled ModelWeb, a toolset for the model-based testing of web application. So let me first start with the quick background information about our work. So our work is based on model-based testing. So model-based testing is to do with specifying high-level models that can be transformed into test scenarios. So here models represents abstract statements about systems, which could be to do with the behaviors of the systems, the interactions and the structures. So those models that describes the systems from different concerns can be used to derive abstract test scenarios, and those test scenarios, abstract ones, could further be used to obtain some concrete test scenarios that are executable with some tool support. In model-based testing is essentially highly active in the area of model-based engineering. There are too many active researchers working on these areas. So there are many different outputs produced day by day. These include the domain-specific language for model-based testings, and also there are tools that enable just for the generation of scenarios from models with different levels of coverage. There are tools that could prioritize the test scenarios using different techniques, including machine learning or artificial intelligence techniques as well. Also, another area of which is related is formal verification of systems, which enables the models to be just proven for particular properties. You can just prove the correctness of the models using formal verification techniques. Having mentioned those, I could now quickly introduce what we contributed in this area. So we developed a tool called ModelWeb, which enables the web applications to be tested using the model-based approach. So ModelWeb is supported essentially with a flowchart-based notation set for specifying the functional user behaviors on the web applications. Basically, our modeling toolset provides a predefined list of actions for the web applications domain. So users use those actions to specify flowchart models in a graphical way. These actions include click, select, open, login, type, share, register, drag and drop, and commands. So those actions are just the user high-level user behaviors on the web applications. So ModelWeb is a tool, as I say. So whenever you specify a flowchart model using the editor provided with the ModelWeb, you could again automatically transform your flowchart model into test scenarios with a path coverage. And those test scenarios are formatted in accordance with the behavior-driven development approach. And we prioritize the test scenarios in accordance with the actual usage behaviors determined via the web analytics tools. But this is not inside the scope of this paper. We later on our tool executes the test scenarios on a given web application using the Selenium web test automation tool, and the results are displayed to the user. Having quickly introduced our tool, I just added a slide that shows how we are different from other approaches existing in the literature. In the literature, there are, of course, many approaches that enables the model-based testing of web applications. So here we just list some. Here, one second. Here we just list some of them, and we just compare them based on a set of requirements, including notation sets for formalism support, focus, and their focus, the support for automated scenario generation, and the support for executing those scenarios automatically. And many approaches essentially are based on state charts. So they just force the users force the users of those tools to use state chart based notation sets. So models are specified using state charts. So state chart is good for essentially formal verification. So because there are many model checkers that can take any state chart models and formally verify those models against some properties. However, state charts may not be so practical for practitioners, especially those with limited level of technical knowledge. So state charts can also get immediately highly complex for quite complex user behaviors. So it may be difficult to understand, difficult to maintain by the users. So and also the app, not all approach provides visual notation set. Some of them provides textual notation set as well. There's only one approach which provides hybrid notation set that enables the textual and visual notations to be used together. Some approach provides formal-based notation sets. As I said, there are many approaches based on state charts. So some of them focus on the formal verification of models. So that's why they use state chart based notation sets. But we should not forget that there's a learning curve here, especially for the formal based notation sets. There's a learning curve because they essentially require you to use some formalisms. So they just derive the state, they just specialize the state charts with some process algebra. So process algebra based notation sets. So their notations are quite complex for practitioners. Because the model checkers, many model checkers accept process algebra based notation sets, which derive from state charts, but they are quite complex for practitioners, which have been already proven by some surveys that I cited here. So as you see, most of those approaches enable the execution of the scenarios automatically, and scenario generation are not always automated. Some of the approaches just enable the user to manually come up with the scenarios from the models. So we observe that our approach is the only one here that offers basic flowchart based notation set. So we do not force users to specify state charts. We just give users a list of a predefined list of actions, and the users use those actions to come up with a flowchart model. So what we do is we just take the flowchart model, our tool produces scenarios automatically, and those scenarios are just documented in behavior-driven development format. We prioritize them, we execute them. Everything I said are performed automatically by the tool. What the users does is they just basically specify the flowchart model of their web application functionalities. So we strongly believe that using flowchart just reduced the learning curve for the model-driven testing of web applications. Also, our tool fully automates the process, starting from the generation of scenarios, their prioritizations, and their executions. So having mentioned about the comparison, so this is our tool architecture. Our tool essentially consists of two subtools. One is the test executor. There's also a modeling tool. So the user use the modeling tool first to specify their flowcharts. And the modeling tool has been essentially developed with a meta modeling technology called MetaEdit Plus. So that's why modeling editor is integrated with a model transformation tool. It's called BDD generator. So I'll explain all those things shortly in a while. So using the modeling editor, users just specify the flowchart models, and those models are transformed into BDD test scenarios by the BDD generator. So these two tools are developed using the meta modeling technology called MetaEdit Plus. Then BDD scenarios are input to a GUI tool that we develop in Java. This GUI tool takes the BDD scenarios, prioritize them if necessary, and execute them on the Selenium web test automation platform. The output will be just displayed to the user in HTML format. So this is the quick view of our modeling editor. So we developed the modeling editor using the meta modeling technology called Meta Edit Plus. So we have such an editor. Here there is the toolbar. Toolbar just indicates the predefined list of actions that could be used. So using those actions, flowchart models are specified. So we start from this screen, by the way. So for each functionality in the web application, for instance, this is the online shopping web application project. So checkout, add to cart, delete from cart, view orders. These are the functionalities. For each functionality, we could draw a flowchart model. And whenever you click on any of these actions, you are supposed to specify some details. I'll explain what they are in a short while. So after you just draw the flowchart models for the functionalities of the given web application project, you could click the link here. The link just takes the models, transform them into BDD, behavior-driven development scenarios. So here is the notation set that consists of predefined action types. For instance, click, choose, select, search, register. So whenever you click on those actions, you specify some necessary information about those actions. For instance, select means just selecting some item from a given list on a web page. So you need to give the ID of the list that you want to select from, and you need to give the ID of the item that you want to select from the list. So these IDs needs to be consistent and with the actual HTML tag IDs, because I'll explain why it is necessary shortly. For instance, search. Whenever you click on the search action, you need to give the box ID. That's the ID of the search box component, HTML component. Here you give the text that you are supposed to write on the search area. And this is the button ID, it's the search button ID. So after you write the text to the box, you need to click some button. So that's the ID, HTML ID of the button. So that kind of information needs to be provided for each action by clicking on the action elements on the editor. So after the models are specified, they are just transformed into transformed into scenarios in accordance with the behavior-driven development. So in each flowchart model, as you know, there are multiple paths that may be existing. I mean, depending on the diamond notation specified on the model. For instance, these are the diamond notations. They just enable the flowcharts to be separated into paths, multiple paths. So each path is just considered to be transformed into a distinct BDD test scenario. So BDD here is just proposed by Dan North in 2003. It's an alternative to test-driven development approach. So with BDD, the main focus is on the high-level system behavior specification rather than writing just test cases that require technical knowledge. So BDD scenarios can be, I mean, behavior-driven development scenarios can be specified in terms of three notions: given, when, then. As you see here, there's a scenario just specified in accordance with the BDD approach. So the scenario is just given with a title, and this here we start with given. Given represents the precondition that needs to be satisfied for this scenario to be realized. So first, the precondition, the given precondition needs to be satisfied. Then then there is when part. The when part represents the actual behavior. So whenever the given precondition is satisfied, the when part needs to be realized, and at that there could be then. Then represents the post condition. So given the precondition is satisfied and the behavior is executed as the when clause, then the post condition needs to be satisfied. So behavior-driven development enables to write scenarios that is easily read, that is easily understood, and also the good thing is there are technologies, there are test automation tools that can understand the behavior-driven development and execute them on the web applications. For instance, Selenium. So given any flowchart model, we just consider each, the first action to be choose action. So the user first choose the browser in which the web application is to be viewed. So that we consider them as the preconditional ways. So it is our given clause. Then for each path of the flowchart model, all the actions that comes after the choose action are going to be the behavior of the functionality of behavior of the scenario. So these are transformed as the when clause, and the last action on the path is always considered as the then clause. It's the post condition. We consider it as the post condition. So upon the user performing the behaviors given in the when clause, lastly the post condition it needs to be satisfied. So for instance here we have a flowchart model for just adding a product to a cart in an online shopping center. There are 4 different paths given in this flowchart model, and each path is transformed into a separate scenario in the BDD format, as you see. So the first action is always the given. The user chooses the Google Chrome. So if this condition is satisfied, the when part is going to be realized. So here we'll just give, here we just give the actions, the action sequence in order for that path. And if those action sequences are performed, the then clause needs to be satisfied. That's the post condition. So user choose the Google Chrome, then opens the Amazon.com login page, home page, click laptops, click Dell product page, and so on, so on. Then the system displays product successfully added. So this is one scenario. So each path is considered as a separate scenario for the add to product functionality. So that's what our tool performs. Actually takes the paths, transforms them into scenarios in BDD format, as you see here. So we have also, so far I've just discussed about the modeling tool, including the editor and the BDD generator. And also we have now test executor. So test executor is not has not been developed using meta modeling technology. We just developed the test executor using Java. So it's just a graphical user interface developed in Java programming technology. Test executor basically performs three important tasks. One is the model extractor. So model extractor is essentially takes any web application source and transform that web application HTML code. It takes any web application HTML code and just extract the structure of the HTML pages. So there are many pages available in any web application, as you see. For instance, for the social media application, there's message, profile, message box, index, people, register, login, follow pages. And for each page here, our model extractor creates the hierarchical structural view that shows the elements in that page. Just for each element, we display the ID and the text of those elements. So this information is important to just associate the actual HTML, actual web page with the flowchart models, as I just mentioned in the beginning. So whenever you click on the actions, there are windows opening, and with those windows, you just associate those actions with the actual elements in the web pages. So to be able to, for instance, know about the actual ID of the list and item on the web page, we developed the model extractor tool that gives those information to the user, and user uses those information to associate their actions on the flowchart models with the HTML components in the respective pages. For instance, search action requires the search box ID and search button ID. Those information needs to be obtained via the model extractor. Okay, so model extractor gives you the IDs of the types and the IDs of the HTML components in each page. So you use those things to associate your web pages with the flowchart model actions. So why this is important? Because otherwise we cannot execute the scenarios generated from the flowchart models on the web application. We needed to find a way to link the actual web application with the model. Otherwise, we cannot automatically execute the models or the scenarios generated from the models on the web application to test the web application against those scenarios. So we have also scenario tester. So I'm not going to discuss scenario prioritizer here. There's also scenario prioritizer. It's outside scope of the paper. However, the tool algorithm or the tool explanations are all available on the web page of this project. So we have a scenario tester. Scenario tester just is accessible via this button of the main GUI of the test executor. Whenever you click the test with Selenium, you come up with a sub GUI, and in this GUI you just give input as the name of the functionality, the priority range, and the scenario file. That's the BDD file. The tool executes those scenarios on the actual web application, and the tool basically runs the Selenium web test automation tool that accepts BDD scenarios and runs them on an actual web application. So we use the Selenium web test automation tool here on the backstage, and we run the Selenium on the backstage, execute the generated test script on the web application, and we display the results to the user. The results include the test duration, the result includes the test duration, test platform, and the BDD scenario tested with Selenium, and the part of the BDD scenario under test, whether they are passed or failed. For instance, here, follow functionality includes a single scenario, and that scenario consists of given, when, and then actions, and all are passed in the test. Okay, because there's a tick here. If there was a cross, that would mean that okay, that part failed to be executed. So to evaluate our approach, we perform performance evaluation. Here, for the performance evaluation, we consider three simple case studies that we just created by ourselves. They are not real systems, so it's a prototype evaluation. So we just developed simple web applications for three domains: social networking, course management, and sports store applications. So we just developed PHP web applications. And we just selected 4 practitioners working for the companies that our research groups collaborates. So each practitioner works in a different industry, including e-commerce, logistics, IoT, and defense. And they completed the software engineering course, so that they know how to draw flowchart models. They're experienced with UML or such kind of things, so that they're quite familiar to modeling. So they have, but they don't have any experience on web programming and web test automation tools such as Selenium. So each participant documented scenarios for the functionalities of the 3 case studies in BDD manually. We recorded time here, in extracting the possible scenarios given any functionality, their documentation in BDD format, transforming those scenarios into the feature file that can be accepted by Selenium. We also recorded here the number of BDD scenarios documented manually. Then each participant has been asked to use the Selenium and test the corresponding web applications for the BDD scenarios specified as a feature file. In this aspect, the participants have used the Eclipse development environment that supports Selenium and perform the following activities. For each web functionality, they write the Java code. They've written the Java code for the step definition. They've written the Java code for the random files that executes those step definition. So the time spent on the above list two activities for each web functionality of each application has also been taken into consideration. Then in the second stage of our evaluation, this time we asked each participant to use the ModelWeb editor to specify the model. They draw the models, they draw the flowchart models for each functionality of each web application considered. The time spent on modeling the flowchart models are recorded. Then the participants have been asked to use again our tool to transform the flowchart models into BDD scenarios. We here just recorded the number of auto-generated scenarios for each functionality. Then the participants use the executor tool to execute those scenarios on the web application. So the tool first takes the transform BDD scenarios, produces the test script for the Selenium web test automation tool, and runs the Selenium to execute test scripts automatically. We just record the time for executing the test scenarios. So we observe that we have considerable time performance increase, and we have considerable performance increase on the number of generated BDD scenarios. So as you see here, these percentages represents the increase ratio for the time reduced when ModelWeb tool is used. These ratios, just increase ratios, give the number of BDD scenarios, the increase ratio for the BDD scenarios that happens when the ModelWeb tool is used. So we see that while the time spans have been reduced considerably, and also the number of BDD scenarios tested got increased very highly thanks to the ModelWeb tool. So also using the ModelWeb tool doesn't require any learning and using any programming technologies. We do not force the users to use Java programming technology. We use some development environments such as Eclipse, and to specify to write the code for the test scripts. Everything has been performed by our tool at the on the backstage. So as I said, there's a web application. There's a web page of the project, and this web page gives further information such as the prioritization algorithm of the scenarios. And we also performed a survey among a small number of users, and we want to learn the usability of our tool. We also provided the usability results on our project website, so you could have a look at them. Usability evaluation results also outside this paper scope, so we didn't have the space to discuss them in the paper, so we just provided them on the web page of the project. So thank you for listening. You could find the tool installation guides, anything else from the website of the project. If any questions, I'm happy to answer.
Thank you very much, Mert. So do you have questions now, as we are short in time, as we also are over our limits for this session? But do you have questions? Just one from my side. Okay, I would intend to ask you about evaluation. So you said something. So what's interesting me, evaluation reports of applying your model is not just in speeding up the process of testing, but in the quality of results. So do you have an idea how to measure improvement of the quality of tested results?
Yes. So with the evaluation, I mean, the evaluation is not so. It's a preliminary evaluation, so we didn't have the chance to perform a comprehensive evaluation. There are many essential threats to the validity as well. I mean, so we in the future we plan to improve our evaluation, but currently our evaluation just considers a very few number of people. As far as I remember, it's 4 or 5. So we just try to learn. I mean, if our approach reduces the development time, the testing time of the web application, and we see with those small number of people, we see that okay, it really reduces the testing time, the time spent for testing, because there are many automations performed, and also what we observed that the number of generated BDD scenarios, the number of scenarios are increased too. So the number of scenarios are increased because we take into consideration each path drawn on the flowchart, but whenever the people ask to just come up with the scenarios, they may sometimes omit some of the scenarios, but if you ask them to draw the flowchart models, they consider many scenarios implicitly as well. So for the quality evaluation, we didn't plan any quality evaluation. We basically just try to learn if in a given time how many BDD scenarios are generated and tested, and how that time is reduced. But quality testing is another question to be considered maybe in the future.
Okay, thank you very much.